So thank you everyone for showing up at 6:30 p.m. on Monday. When I was asked to be a panelist, I was asked to be against this technology. However, 60% of my research is in 3D printing of concrete. So I actually against the conventional way of 3D printing, not against the technology. If I ask you, if you have someone give you Ferrari or Lamborghini, but limited you to drive at 15 miles per hour, what will you gonna be doing? You'll be frustrated, right? Because the technology can unleash a lot of opportunities, but we actually limiting ourselves by the way we conventionally design structures. So I use this slide everywhere. If you have my presentation yesterday, I always ask, what's the difference between the two images? The left one is 1950, the right one is 2019. What's the main difference between the two images? Black and white, right? So for 70 years, we are building the same way with a little bit advancement in the technology. So today, I'm just trying to show new approaches and what can this technology actually unleash. I also work on the other side of metal printing. So if you are familiar with metal printing, there is like 7 different techniques to do printing, from laser sintering to powder bed to others. And if you talk to material people in this area, the material is so expensive, the process is so expensive, so they do 2 things. They customize design and they optimize the design. So if you want this technology to succeed, my opinion is you have to optimize your structure, you have to customize it if you want, but we are always confined by the code. It has to be according to code because we are dealing with safety, right? But so my presentation today will focus on what's the difference between the technology. We have conventional construction where we form, we put reinforcement, place reinforcement, and cast. This is for years. The right side, I call it hybrid construction because we print, after we print, place reinforcement, and we cast. So I don't call it 100% 3D printing. The last one in this side that you can actually come up with a larger structure that is optimized, bare material, you place the material where it's needed. So we did this test last couple of months, and this is very similar to Moini's approach, but for different reasons. I know Reza got his career award in this topic, so congratulations. So one of the area here, we try to print in different printing paths to see the differences in module of rupture for another application. So the first one is longitudinal printing, where we have 7 beads and we build up 3 inches. The second one is transverse printing. You can see actually side by side layers. And the third one is iterating between longitudinal and transverse. If you can see here for beam 1, 2, and 3, we have a very nice fusion between the layers. If you actually crop the outer layers, you can think it's cast in place in some cases, but the third one, you still see the layers. My objective here is if you normalize all the results to get models of rupture, our material gets us between 900 to 1,000 PSI as a models of rupture. So one thing we're actually trying to do now is go back to some designs where we can be compression-only structures or optimize the structure based on compression and tension. So the first one is arch that we printed. You can, by material calculation, you can assume the main arch and the horizontal slab are equivalent to just 2 layers of horizontal slab. If you back calculate from models of rupture, you will see that you will have 135 pounds that can carry by this equivalent beam. When we tested this one, we actually carried 1,349 pounds, which is 10 times just by varying the printing path. So we also can use this technology to lower the carbon footprint of our structures. We do a lot of work on area of low carbon materials. This is one of the in-house mixes that we developed for geopolymer concrete. And this is cementless material. I think I have a video here that shows initial, I don't think it's, yeah, initial printing of this vase. This material is a little bit tricky. The open time is very short, within 10, 20 minutes. We actually have the syringe tube that we have in our lab in the printer that actually, a couple of those tubes actually shattered during the print because it sits in the syringe tube. We also optimized compression-only structures. You can see here this was an grad research where we asked the student to get design from compression-only structure with arches all over the world, and we came up with different design and was able to print most of them, and we will be testing this very soon to compare it to cast-in-place conventional construction. We scaled that up. We actually last week were able to print, because our printer can print 20 feet by 7 feet by 7 feet volume in one setup. So this one is actually an arch bridge or element that we printed with commercial material, and we will be testing those very soon to ensure the compression designs that we have. This is one material that we developed in Rowan, and this is the printing of it. I accelerated the printing because it is 20-minute video, but this is the actual speed, so I slowed it down so you can see this actual speed. This is not a 2K material, so we were able to print in, I think, 20-degree slopes, and this is the actual speed based on our material. This nozzle is 1-inch nozzle. The one that I showed before was around 6 to 8 millimeter nozzles. And now I continue to print, and this was by the material that we developed. Our material strength can go up to 12 KSI in 28 days. In the back, you can see the other one. Here is another print that we did with a 2K, two component, where we have the accelerant. Yeah, this last slide. The accelerant that actually, as second stage, added to the nozzle, and there is agar in the nozzle, and this is an actual speed. This technology actually, and those actually set the material or the layer instantaneously, so you can actually come up with very organic and curved prints. And this is the end of my presentation, but as I try to advocate for this technology, try to think of how to use the material, less material, so less carbon footprint, architecture designs, optimized designs, and multifunctional design if you need for this application. Thank you very much.